What is up, Internet? It is I again, that guy again, and today we're going to be hacking some more Kingdom 1 Hearts Final the Mix. And this episode is going to be more of a stepping stone than anything, right? Last episode we updated our warp cheat to where now we can just pause the game, turn on our warp cheat, and then actually type in whatever room we want to go to. So like, I don't know, shoot. Let's say we want to go to the clock tower in Neverland, right? See, 13, 14, 15, 16 is definitely not Neverland. Hold up, 10, that's lab entryway, 9, Tranquil Grotto, that's like the mermaid level, that's what it is. We'll find it, y'all. Is it 13? Oh, it's 13, okay. So then we just go through now, and we just gotta find the room, right? Is it room 10? No. Room 0? No. We can just literally go through every room and check the name now, right? Whereas before, we could check the rooms. There's clock tower, right? So now we're just gonna unpause. Sometimes we gotta do it twice, I'll admit. There we go. Now we don't have the power of flight though, so we are kind of screwed, but we are at clock tower because of the power of our warp cheat, right? And actually, because of our warp cheat, we're not screwed. Even if we fall off the edge, we can just pause and we can go somewhere else, right? So like, let's say we want to go to, let's go to Monstro, bro. Let's go to Monstro. That's what, room 12 or world 12? Yeah, let's go to Monstro. But see, our power is limitless, basically. We can do whatever we want. We don't even have Donald and Goofy. We're in Monstro. We're swimming around, right? So we kind of, at this point, like, we have power, right? We have a bunch of power. The only thing better we could have at this point is more information. And if you'll recall, I mean, so like, one of the best types of information you can have is figuring out how to link your current information together, right? So let's say this. We know so far of the existence of the structure for entities, right? Which are anything that can move in space, things you can lock onto, that sort of stuff. We also know about the stat page and the party stat page, right? Which are used to contain health and strength and stuff like that for things in the world. We know they must be linked together somehow because, well, simply like when you lock on to Leon or you lock onto something, the scan ability shows you the health, right? So it's got to be able to find that somehow. So the only real question there would be, you know, how exactly do it do that? How do it be linking things, right? And so what we have is we have Sora's information, right? We have Sora's stat page. And what we can do is we can actually go and find out what accesses this address, right? And we actually notice every single frame something's accessing this address, some bit of code, right? So let's actually take a look, share the disassembler, full screen that bitch, and we're actually, let's do this. Let's go here. Since this is the only code accessing it, we'll just say break on, well, let's go browse this memory region first, right? And then we'll click it and we will say break on access. There we go. All right, so we broke on access, right? Delete that breakpoint. There we go. Here we are. So if we look at it, it's the code that hit the breakpoint right here is this test byte at the value of racks, right? It's, or the A pointer, right? Which if we look in the A pointer, it's this D610 address. It's the address we're looking at, right? So we might wonder, I guess you would say, like, how exactly are we getting this A address register, right? How are we getting the value of Sora's stat page is the next question we would really have logically, right? Now to find that out for sure, we actually kind of have to set some breakpoints up here and like travel through the code to see what's going on, because there's this function that gets called, this 38BOBO or 38BOBO if you want to have fun with it, right? And that might manipulate the value of this A register, right? But what we can see beforehand, right? Now, usually when you are messing with functions, the A register is the return value of that last function, right? Which is why we don't know for sure unless we look at 38BOBO and what's going on there. But usually, and this is true in this case, the C register is used for parameters, especially in a single parameter function, right? And we can see right before 38BOBO gets called, it moves into the C register a 4-byte value from the pointer referred to by RDI plus 6C. And if we look at RDI, it's a memory address ending in B8F60. So let's look and see if we have any memory addresses that look like that, right? And actually, lo and behold, that's a pointer to Sora's entity right there. So RDI, which is Sora's entity, plus 6C, so every entity plus 6C refers to a value. That value is this 4-byte value. In this case, it's 847D D610, right? Pointers are 8 bytes in modern systems, and honestly, the reason this game does this is it's a carryover from like the old engine, but you won't see this often. But we've learned that basically at 6C from the entity is a 4-byte value that can be decoded by this 38 Bobo function. It can be decoded and turned from a 4-byte pointer into the 8-byte pointer we need. And honestly with you, we're going to see this everywhere in this game. And we could go through 38 Bobo, probably will later, see how it does what it does. But for right now, we're just going to understand that we can use that function, right? So we're going to take our handy dandy notepad, 38 Bobo, decode function, right? And then, so at this point, right, here actually, let's go back. And then, do I have any breakpoints? No. We're going to run everything, right? We're actually going to put a breakpoint here. And we have, it looks like the same entity, 8F60, RDI plus 6C. It's going to be put into the ECX register, right? And then we're going to call 38 Bobo. And you're going to see why I skipped it, right? It's going to first test the value in the C register, make sure it's not 0. If it is, we're just going to return 0, but if not, we will continue the function. It's going to preserve the B register. It's going to subtract the stack pointer. It's going to move the basically 4-byte value into the B register. And it's going to call another function, right? This is where shit gets hectic, right? And honestly, I don't even know what some of this stuff does. I've re-implemented it in C# before, but a lot of it's just kind of copy pasting what you see. But it's using a lot of pointers to construct a pointer and all kinds of fun stuff, right? So yeah, better left alone unless you want to have, like I've been looking at this function for months and I still don't have a full understanding of it, but we do know that the function, once it runs through in the RAX register, it leaves the pointer we need, right? Takes a value from RCX, leaves it in RAX, right? So when we implement it in code though, we're going to want to know for sure what all registers it impacts, right? So we know what we need to preserve. So we're going to go back to the first breakpoint and then we're going to run again. And we're going to see the registers that change between runs are the RAX, RCX, and RDX registers, the ones that are red. So we're just going to go notate that RCX and RDX, right? So now real quick, since we know that 6C from the entity, right, we're going to edit our Sora entity thing here. At 6C of an offset, we see 10 through 38. Okay, cool. So we're going to add an address in here, right? We're going to say it's plus 6C. And it's going to be, we're going to call it so I call these 4-byte pointers, right? And I'm trying to think if there's a better term for it, because this is kind of where we're making the term, right? Let's call them short pointers, man. I like that. That's better. We'll call them short pointers, right? So we're going to say this is the stat page short pointer. I want the P capital because I'm that kind of guy. All right, and we're going to actually have it display as hexadecimal, right? So now gonna have to drag it to where we need it. There we go. And it's gonna show us the stat page short pointer, right? But the thing is, in Cheat Engine, we can't just directly like double click this and get there, right? We have to actually do the weird math, do the function by hand, which we don't even know how to do right now, right? To get to the address. So we're actually going to implement into our cheat table a way for us to be able to automatically convert to and fro, right? We want to be able to take the 4-byte entry and convert it to the full pointer. And actually, we also want to be able to do it the other way around. So that way, maybe we can change things, right? We can change Sora's stat page and flip it with Donald's or whatever if we want to, right? So let's say this. How are we going to find the function that encodes it? We already have the one that decodes it, which is 38 Bobo. We need the one that encodes it, right? And to get that, so since we know that the 6C area is where, like we know this is memory that's going to refer to the stat page short pointer, what we're actually going to do, we're going to turn off our breakpoint. Let's actually look at something, right? We walk into chamber 1. Hopefully it doesn't crash. Ah, fuck. So, one thing I forget to mention, Monstro, very buggy. Very, 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 very buggy if you go there early by hacking the game. So, I'm gonna start again when the game loads up. Alright guys, the game has reloaded. We're gonna go back to Sora Entity, we're gonna go back to our little 6C area, because actually, this is a good time to point out. So like stat page short pointer is at the address ending at 7D06, or 7D0C, right? But the address we were looking at is this 8FCC, right? And that's because, like we discovered before, Sora's not always at the same place in memory, like or Sora's entity, right? Because it's actually an array where, you know, depending on the room, depending on the art file, depending on the scene, Sora or whatever entity may be wherever he's placed in that file, basically, right? So we'll actually probably look at the entity list later and reverse engineer how that works. This piece that we're going over today is going to be critical in doing that because, like we're seeing here, the entities have references that are encoded in these 4-byte short pointers that we actually have to figure out how to manipulate, right? So we're actually going to go. We know that in this room, particularly in this scene and all that, that this is the address where Sora's stat page short pointer is going to be at. Sorry, that's a tongue twister, right? So we walk out here, right? And we actually see it now, it's a different one. It's a D510. And Sora's thing's always D610 we've seen, right? So that's referring to something else. I've noticed the D510 stat pages are actually the ones that are like inanimate or dead objects. It's like the one before Sora. But now, so before we go back in this room where we know that Sora's stat page is going to be populated at, we're going to right click. We're going to find what writes this address, attach the debugger, and then we're going to meander on through the store. Cool, so we actually have 3 instructions, right? And we can actually look in the briefing of the instructions. Let's see. Oh well, that didn't do what I was hoping it would do. It didn't tell us shit. Let me see. There we go. So one of these is RCX plus 40. That's doing some different shit. That's something about memset. We ain't gonna worry about that. But we see 2 that refer to RDI plus 6C. So that's what we're looking for, right? I'm gonna show disassembler. And so the function that we found before, we're going to recall, was 38 Bobo. 38 BOBO, Bobo. Now, we see that this code moves into here. Actually, let's just put a fucking breakpoint on it, and then let's go through a room. Let's load a room. Let's watch it. So, the value of RAX, register A, is this D510, right? It's going to take the EAX, which is the 4 bytes at the end here, and it's going to store it at RDI plus 6C, right? Step into, it does the thing. There it is. Awesome, right? Let's actually go and we're just going to step into this function and we're just going to step out of it. And all of a sudden, there should be, weird. Where's our pointer at? Where's our pointer? What? Hold up, y'all. Maybe I'm tripping. Because, so, let's start again. Let's start again. So, let's actually go until we get Sora's, which is D610. We're just going to keep going, keep shuffling on through. I want D610, please and thank you. How many fucking entities can there be? There's like 50 on the beach, actually. Surely we almost have gotten Sora. Here, let's just go in here. There's less entities in here anyway. So D510, 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 D510. There is a way to set a conditional breakpoint, but I don't feel like dealing with that shit. Yo, what? For some reason. Well, that's okay. There was another one we could look at. Sometimes things just don't be going my way and I just look at a different function, or I just keep looking at it till they do. But, so let's see. So actually, BO80, right? I like it better here because this one would actually, let's put a breakpoint here, right? And let's walk in here. And so we can see, all right, cool. So it's going to take the value in RAX, which is the entire, there we go, this is the entire pointer. That's what we want. So it's going to take the value in RAX, put it in RCX, which is the argument register, right? It's calling 38BO80. I don't have a cool way to say that, but that's our encode function. And then we'll call it, step out, and then in the A register is the short pointer. So it takes the C register and then stores it in the A register, just like the other one does, right? And so let's actually see something, right? Let's break there, and then I want to get up to the first one. I want to see what registers are affected. So we're going to hit run. It's the C register, the D register, and the A register, just like before, but also the 8, 9, and the 10 register. So we're just going to have to preserve those as well. Very good. So now we know what we want. And as far as our plans, right, I want something in our cheat table, an entry here, where we can go. Actually, let's kind of preface this, right? So these are going to be addresses that don't exist in the game. We're actually going to use custom memory in our cheat table because it allows us to do fun things like this, right? So we're going to put 0 for the address to start out, right? And this is going to be, we'll say this is the short pointer, right? Let me think here. Yeah. Okay. Hold up. Because I'm trying to think, are we going to have 2 fields, one for entry, one for output, or... Yeah, we're going to make 2 codes, actually. We're going to make 2 codes here. That's what we're going to do. So for this, we're going to do short pointer. We're going to do hex. We're going to say OK. And then we're going to add another one that's just going to say pointer, right? This one's going to be 8 bytes. It's going to be hex. It's going to be great. Awesome, right? And so now we're going to select both of these, add to new group. And then this one, we're going to say short to long, right? Do I want address version? We're going to say yes. And also, so we're going to structure things, right? In our custom memory, for each of these 2 fields that we're going to have, the short pointer is going to be the first part of memory, which is going to take 4 bytes. The pointer is going to be the last part. It's going to take 8 bytes, but it needs to start at a +4 offset. This one needs to start at a +0 offset. Now, short to long, that's going to take a total of 12 bytes. So we're actually going to copy this, paste it, and then actually instead of short to long, we're going to have long to short. Cool. And so something I should have done before copying it is, hide children when deactivated, make things clean. Do the same for this one. We know this is 12 bytes, and so we're going to say, so 12 in hexadecimal is, I always got to think about this, A is 10, B is 11, C is 12, right? So plus C. There we go. And then we'll put both of these, group can add a new group, and then we'll say pointer conversion. Pointer convert, right? Do we want address version? Yes, we do. It's going to be important. And then might as well drag this to the top for a moment, make it easy. So now we can see all these and see what's going on with them and get more information. Cool stuff, cool stuff. So this is going to be the fun part, right? We're going to get to make our code. So this is something that we're going to want running every frame, right? Every frame that we enable it for, because we don't want to have to like pause and unpause every time we want to do a conversion, right? It's just going to make things clunky, slow, silly. So we know that we had a function we saw that was running every frame when we went and we right-clicked this and we said find out what accesses this address. Right there, right? Show disassembler. All right, cool. So this runs every frame. Let's see. Here's what I'd like to do. I'd like to see the function that this is in real quick. So we're going to step out. Oh, geez. So sometimes you'll see this, right, where it calls like the value in RDI plus 10. That's a mess. We'll go into that a little bit later. But from what we're able to see, it would call something at the start, at the top here usually, not always. We're going to have to test it out and see. I just hold up until I see like a bunch of int3s usually, but if you start going way far back like this, oh well, here's our int3s, right? So I don't think we have any breakpoints. There we go. So we're going to put a breakpoint here at the top of this function, right? Just see if we hit it. And we do. We consistently hit this frame, or hit this every frame. I'm loving it, right? So at the start here, move stack pointer to racks. See, that just something feels weird about hooking in right there at that part. We're going to try it though. We're going to try it. We're going to see. So as before, Control plus A, auto assemble. I'm going to say template. I want to do cheat table framework, code. We want to do code injection on this 295E50. We didn't write it down because we were being silly, but we need 38B080 for our encode function, right? All right, so we're going to have some fun here. We're going to have some fun because we're going to learn today about the register symbol, which I'm going to have to remember because it's been a minute, right? But let's do this. I can't recall. I actually do need to Google something. We'll Google it live, right? Register symbol. Oh, it's in my history. How nice. Okay, so register symbol, I think you do have to define it. Okay, hold up. To the user defined symbol list, it has to be declared. Okay, that is what I was looking for. Yeah, so you do have to label register because we're going to have to allocate memory for it, is what I'm thinking. And so what we'll do is at the top here, we're going to say alloc. We're going to call this pointer info. And how many bytes are we going to need? Well, we can do the math on this. Actually, let's close this tab before it eats my resources. We can do the math on this, right? Because we're going to need 4 bytes, 8 bytes, 4 bytes, 8 bytes, right? So really that's just 3 times 8 bytes because 2 4s and then 2 8s. So hold up, brain fart, 24. 24. Okay, so we're going to need 24 bytes. Is that right? 4 bytes, 8 bytes, 12, 20. Yeah, 24. Okay, sick, sick, sick. Doesn't really matter where this is stored. We may as well just copy this though so it's close in memory. There we go. All right, so we've got the space allocated. Now we need to register symbol, right? Pointer info. There we go. That's going to let us use it in our cheat table. And so now we're actually going to go down here though too, because when we disable the cheat, we want to deallocate the pointer info. We want to deregister symbol. It's unregister actually, I'm sorry, unregister symbol. Yeah, the pointer info. Okay, cool. So now for our new mem, the code that we write, what we're going to do is we're going to do 2 things, right? We're going to basically go in, we're going to take from the short to long, we're going to take the short pointer and we're going to move it into the long point, or we're going to convert it and put the result in the long pointer. And then same thing in inverse with the long to short, right? But also, as you'll recall, we have to preserve these 6 registers. So before we do anything at all, we're going to say push racks, push RCX, it was racks. All right, ACD 8, 9, 10. Okay. 8, 9, 10, right? Then we'll pop them in inverse order at the end of our code. All right, very good, right? So now we've got that done. First, we're going to do the short to long, right? Now, short to long is actually, oh, here. So when we go in the cheat table too, we're going to go to pointer convert the group, right? We're going to right click, parentheses, and then inside the parentheses, the name of the symbol you register, right? It's not going to reference anything yet because we haven't ran it for the first time. We're also going to group config and hide children when deactivated, just so that's done. But it'll tell us, right, like the offset at which each thing is at. So the short pointer is going to be at a 0 offset from pointer convert, or from pointer info. Hold up, is that what I called it here? Oops, pointer info, that has to be right. Has to be right. Oh, actually, I guess if it's right, it'll give you the little thing so you know. That's cool. Anyway, so we know this much, right? We know that we want to take the 4 bytes here and store it into RCX, and then we want to call the, okay, cool. So we're going to say move into ECX, so it's 4 bytes, right? Comma, and then it's going to be pointer info, plus 0. Or we could just say pointer info. Rather, we're going to want to make sure it's in square brackets so it knows the value at pointer info, right? Pointer info plus 0, which is, pointer info. So we're just going to say that. After we do that, we're going to want to call the function that is our decode function, right? Which is 38 bobo. So we're going to say call kingdom hearts. Oop, gotta spell kingdom right. Final mix.exe. Fuck. Oh man, I'm just messing up left and right today, huh? Okay, there it is. Kingdom Hearts final mix.exe plus 38 bobo. Something feels right. Something don't feel right, but I'm sure that's okay. Call that. Yeah, that'll work. That'll work, I'm sure. All right, cool. So now in RAX is the actual pointer itself. So we're going to say move into the value for pointer info plus 4 RAX. Cool. First part's done, right? So now what we'll do is we'll take care of the long to short. So now we're going to have to say move RCX, the value stored at, by pointer info plus, for the pointer, it's going to be 10. And then what we'll do here is we'll say call Kingdom Hearts final mix .exe plus 38, what was it? 38bo80. Sweet. So now that we've got that done, right? Now that we've got all of our fun little shenanigans done there, it's going to return in the A register, it's going to return the 4-byte pointer, right? The short pointer. So now we're going to say move hold up. Okay, there we go. We're going to move into the memory value referred to by pointer info plus C, right? For short pointer and the long to short, the value in RAX, right? And actually, that should be all we really need to do. Looking at it, who knows? It might break, it might not. But what we're going to do is we're going to hit execute, code can be injected, yep. And why did it do that instead of, is it in my cheat table? Oh, you know what? I'm being silly. You got to click file and assign to current cheat table. LOL. All right. So I don't know what injecting it's going to do like that. Well, I know this actually. We can turn it on and then turn it off and it'll uninject itself. Although something, I don't know, man. Let's just run it. It didn't crash, so there's that. That means a lot. So we're going to name the script. We're going to call it pointer info. And we're just going to drag the script somewhere that makes sense, right? We're going to put it into like right here in the pointer convert group at the top. And we'll turn it on. Let's just see if it crashes or what it does, right? So sometimes I've noticed you have to right click and you have to say force recheck symbols. That doesn't seem to have done anything. I do see, let me put a breakpoint here. Is this getting called? No, it's not. How strange, how strange. Let's click back. Okay, is this getting called? Yes, okay, so we're gonna hit this, we're gonna see what goes on, guys. So, pointer info, let's go over here. Pointer info gets moved into RCX. The value at pointer info is apparently 0. And then it does call 38 bobo. 0 is put in RCX. Is this plus 0? That's why. This needs to be plus 0. Maybe that's why. Is this 0? This is plus 0. This is how you debug, fellows. This is how it goes. Although, so I know, let's do this, right? Let's just go ahead, let's copy this memory address, Control G, Control V. So now we're in the spot. It's probably going to start with the zeros here. There we go. All right, we're in the spot, guys. We got the location. Let's see something, because there's got to be some kind of rhyme or reason as to why. Let me see. Force recheck symbols. And then it's just not finding it. So we're going to change script. Register symbol pointer info. pointer info is a registered trademark of our code, but for some reason it is spelled correctly, it seems. Let's look at the documentation for register symbol. This episode's a little bit longer than I expected, folks, but we are almost situated. Maybe it's because we didn't define it. Maybe it's because we got to define that shit. User defined symbol list. I can use that name instead of an address. Yeah, this should be working. Let's look at the define. Advertisements sponsored by Cheat Engine. You know what, Maine? You know what? We're going to try to define. I don't think you have to undefine. Yeah, we're just going to try to find. We're going to see if that shit works. So, allocate, register symbol, define pointer info. I feel like we should have it defined previously. Let's just define that shit like up here at the top, at the very tippy top. Yeah, it makes me feel good about myself. Okay, so we're going to, not all code is injectable. Define name, whatever. This is one of the most programmer moments of all time. Okay, we're going to go back. We're going to look. Define. Okay, so you have to define it with a thing that's going to be replaced. Well, fuck, that's not going to work. It's not going to work at all. So this should be working, bro, because we've got the symbol registered. Let's delete that. We got the symbol registered. We got it allocated. We got all this shit going on. We got label return here. Let's hit OK. Maybe we got to label it. I don't really know at this point, y'all. Here. So we're going to right click this, force recheck symbols. Boom, boom, right? Force recheck symbols again because I'm just going crazy at this point. It really ain't finding that shit. Let's just try this. Let's just try typing. Bro, I'm an idiot. You just type pointer info. So you don't use the parentheses, guys. You just type the name. I swear you used to use parentheses. No longer. No longer, fellows. No longer. So let's run. Let's turn off our breakpoints. Let's try it, right? So we know, based on our experiences we got in the Sora entity, I'm going to click on that shit. I'm going to go down, and we're going to take this, the short pointer for stat page, right? Gonna go back up, put it in short to long, boom. And we'll take our long pointer, put it in long to short. Well, oh boy, something's not right. Oh, you know what? So we noticed something, right? It's not putting the right value there. So +4 +0, 10. +C +D? Nah, it's never that easy. Never that easy at all. +C. So we got one more bug that we must iron out, it seems. And I wonder something, right? Let's see. So we're gonna say find what writes to this address, right? Gets written a bunch because we are executing every frame. So it moves into, so there's a problem here, right? And you can tell because it's moving it into 80C, and we need it to move into 810, right? And actually, I think I know what our problem is. Let's go ahead and turn this off. We're gonna say change script, right? So, yeah, I'm seeing the problem here. I don't know what I was thinking. So we're moving an 8-byte value. RAX is 8 bytes, and we need it to be 4 bytes, right? So we need, instead of RAX, we need to say EAX, and then hit OK. And then we're going to turn this on. There we go. Let's just put our long pointer in here, and there we go. There's our short pointer. And now put our short pointer in our long pointer, and there we go. So yeah, guys, that was a extended video that we're going to use a lot of things from here on our next video on, but now we're able to convert between pointer types in Kingdom Hearts 1, the final mix. And I'll see you guys tomorrow, okay? Thanks for watching.